All right, what is the tonnage of a chiller? We're talking chillers now. Having a flow rate of 200 US gallons. That's important, by the way, because there's a difference between a US gallon and an imperial gallon, and we have equations that relate to US gallons. To convert to imperial gallons, you would need to multiply by 1.2 because an imperial gallon is 1.2 times the size of a US gallon. So don't forget that. But anyways, our chiller has 200 US gallons per minute. That's our flow rate, our GPM. And then we have an entering water temperature and a leaving water temperature. So this is referring to our chilled water barrel. We're going to be entering, obviously, at a warmer temperature, 55, and chilling the water to 45, and then pumping that chilled water around to air handling systems, which is wonderful, and that's normal. A 10-degree split across a chiller barrel is pretty normal. So we need one equation, and here it is. Q, which is going to be your BTUH, okay, or your number of BTUs, actually. Q is going to be equal to your gallons per minute, so GPM, and I want to write here US because this equation is for US gallons. If anytime you're asked about imperial gallons, just multiply everything by 1.2. And that's going to be multiplied by a constant, which is the number 500. Don't worry about it, just accept that it is the number 500. And then we multiply by the change in temperature across our barrel or our coil. We could be talking about a chilled water coil. In any case, we're going to be able to figure this out. So let's substitute our numbers in now. We have 100 US gallons. So I'll put in, we have 200 in our question. We have 200 gallons per minute US, 200 gallons per minute US. That's our flow rate of water through our chiller barrel. Times the number 500, and then the temperature difference in this case of 10 degrees Fahrenheit. Okay, so we'll quickly multiply all that out. 200 times 500 times 10, and we end up with 1 million BTUH. Okay, 1 million BTUH. But our question's asking about the tonnage. Well, we need 12,000 BTUs per hour for every ton. So I'll just take that number, divide by 12,000, and see what the answer is. So divide by 12,000, and you end up with 83 tons. In fact, I calculate 83.3 tons, but the closest answer in our options is 83. So we've got a nice equation here for US gallons per minute, and it can apply to any time you have a scenario where you have a chilled water coil, you know the flow rate, you know that it's US gallons versus imperial gallons, and you know the temperature rise or temperature drop across the coil. That's all you got to know, right? Now, if the question was an imperial, you just take everything and multiply your answer by 1.2, and you would have your answer. Okay?